Hello student, today we are learning about a new topic. It is just you can say out of syllabus, but here we study because it is just an application of Newton's second law of motion. This is free body diagram. When all the forces are discovered by Newton, that means balance force, unbalanced force, then a very important force also developed. It is known as the special types of forces in physics. These are tension force and spring force. Tension force is just developed in string and spring force is developed in spring. When we stretch a spring, then the deformation takes place and spring have applied own force to reduce against the external forces. That means he wants to change itself. That is known as spring force. Similarly, when we stretch a string, a rope, then an extra force acting by the string against the applied force, that is known as tensile force. So FBD, that is free body diagram, is just an application of Newton's second law. And here today we study about the formula of tension force and acceleration developed in a body in a free body diagram. Now let's see on the board. The topic is free body diagram. Here we have a frictionless and massless pulley. You know about the pulley. Pulley is a movable metallic wheel. So here we have a pulley and a string is over the pulley in which two masses, that is M1 and M2, are connected in both the ends of the string. So when they are hanged in the parts of the string, ends of the string, then it arises a force in a downward direction. That is M1G, that is the weight of the body, and M2G. Due to these forces, there is a stretched elongation developed in the string. Due to that development, stretchness, string applies the force that is known as tension force. There T is the tension force. Now here we apply the unbalanced condition of the body. Now if M1 is greater than M2, we should take a condition that if M1 is greater than M2, then M1G is heavier than M2G. So the wheel rotates in this direction. And M1 moves downward direction. And M2 moves in upward direction. So as, let's consider the acceleration developed in M1 is A and in M2 is same as A. So M1 body moves downward with an acceleration A and M2 body moves upward with the acceleration A. Now, by these conditions, we calculate the value of tension force and the acceleration developed in the string by a simple formula. Now let's see. If we just talk about M1, अगर हम M1 की बात करें, अगर हम लोग M1 की बात करें तो हम देखेंगे कि M1 पे दो फोर्सेज लग रहे हैं. देयर आर टू फोर्सेज अप्लाइड ऑन M1, दैट इज इन डाउनवर्ड डायरेक्शन M1G and in upward direction tension. But this force is unbalanced. How? Because M1 moves in downward direction. Then the net force on M1, that means we can say net force, total force on M1 is just move in downward direction. So we can say that the net force, we can say that M1A, that is the net force, this is the net force, is equal to M1G minus T. Clear? This is equation 1. This is the net force because M1 moves in downward direction. So these forces are not a balanced force on that body, that system of the body. If it moves in downward direction, then M1G minus T is equal to M1A, the first equation. Similarly, if we talk about M2, then the tension force applied on upward and M2G in downward direction. Due to this, it moves with the acceleration A in upward direction. So for this, we can say that M2A is equal to T minus M1G. That is equation 2. So from equation 1 and 2, by adding equation 1 and 2, we get. Now I want to erase the board, so please see carefully. We have two equations. M1A is equal to M1G minus T, unbalanced force condition, and M2A is equal to T minus M1G. So from equation 1 and 2, by adding, we get TV cancels, M1A plus M2A is equal to M1G minus, this is M2, M1G minus M2G. Therefore, A or we can say A into M1 plus M2 is equal to M1 minus M2 into G. Therefore, A is equal to M1 minus M2 by M1 plus M2 into G. This is the value of acceleration. This is equation 3rd. This is the value of acceleration of the body. Now from equation 1 we have, from equation 1 we have, equation 1 is M1A is equal to M1G minus T. So we can say that T is equal to M1G minus M1A. This is the tension force. Or T is equal to M1G minus M1 into A. A is the M1 minus M2 by M1 plus M2G. Now, G takes common and we can write M1 minus M1 square minus M1 M2 by m1 plus m2 g. Now again T is equal to m1 square plus m1 m2 minus, sorry, this is plus, that one minus plus, minus m1 square plus m1 m2 or taken minus if we take common by m1 plus m2 into g. Therefore T is equal to 2 m1 m2 by m1 plus m2 into g. This is the value of tension force. From these equations we can solve all the equations related to Newton's second law under free body diagram. Thank you for today.